Good evening, students. Work in energy is the next chapter, that is from the physics only. So you have to focus on the numericals also. Basically, the chapter is named, as we know, work and energy. But along with that, the third term is there, that is known as power. Okay. So work, we will read about three things in this chapter: work, energy, and power. So what you have to learn, like you are learning in the physics, the formulas. Okay, so you will learn the formula. I will make the table also. The table I have not included in the notes. So right now, so see about the explanation what we have to learn in this. So first one is work. The first quantity is the work. Okay, so work is what? The formula of the work is force into displacement. Now you will say why the displacement is small s. Okay, so they are having, I told you that one quantity can have more than one symbol. So the same thing is here. Like we have learned in the motion chapter, capital S is distance. So here the small s will be displacement. Okay, so the formula of work, the definition is it is a product of force and displacement. Okay, force into s. Now symbol is capital W. So formula symbol, then it is unit. What is the unit here? What is the unit of force? The force unit is Newton, as we have learned in the motion chapter. Then s, it is a displacement. So displacement unit is meter. So total unit of the work will be Newton meter, or another name we will give, that is joule. So if any question will come, what is the unit of work, what you will write down? You will write down it is Newton meter or joule. So joule and Newton meter is the same one. Now the second one is CGS unit. Now you will ask, what is CGS unit? So first one is this international standard unit, and CGS is the second type of the unit. So many type of the units are there. As soon as you will go 10th, 11th, so you will learn more than one unit. SI unit, the main thing is you have to learn according to the questions. So if the question will come, what is SI unit of the work, you will write down joule. If they will ask what is CGS unit of the work, it is erg, ERG. 1 joule is equal to 10 to power 7 erg. You have to learn that only. What is the relationship between joule and erg? 1 joule means it is greater than the erg. So joule is a bigger one, erg is a small, because you can see 1 joule will be 10 to the power 7 erg, means 7 zeros. Okay, now what is the nature of the work? It is a scalar quantity. Scalar quantity means it is not having any direction. Vector quantity means it is having direction. So all the quantity in our physics, there are two type, scalar or vector. Vector means having the direction. Scalar means they are not having the direction. Like mass, no direction, only the value. A value with the direction, for example, we are having the velocity. The velocity is what? It is having the direction. Okay, now the another one, like the normally we are saying work done. Okay, if you are sitting on a computer, so you will say, okay, you are doing the work. But in physics, it is not known as a work. When you will say that work is done, only when two conditions are fulfilled. What are the two conditions? If the force, if you are applying a force and you can see the object is moving, means some distance it has moved, then you will say the work is done. But if you're sitting on a computer, you are only typing, but that word document is completed inside the computer. It is not, the computer is not moving from one place to another. You are working on the computer, so your force is on the computer. You are doing the force, you are applying the force on the computer buttons, but that computer button are not going from one place to another place. That's why your work is zero there. Force is there, but work will be zero. Normally when your mama will come, you will say, okay, I am doing the work. But in physics, force into displacement, if one thing is absent, your work is zero. So we will see, okay, two type of the examples we will see. Okay, now we will see what are the two type of the example. Okay, now see, where you will say the work done, where you will say work is not done. Okay, so see here, if you are pushing the table, you are applying the force, but table didn't move. If the table didn't move, it means it is very heavy, then you will say that the work is not done. Okay, now the second one is what? You see the push, you are pushing the table, if it is moving from A position to B position, then you will say work is done. Yes, the work is done. Okay, means S should be some value. It means displacement should be there. Okay, now we will come to this next. Okay, now you will see I have given you one form numerical. This kind of the question we will do. Numerical we will do the in the like during the in-text questions and the exercise question also. Now you will see here this one. Okay, this one is a force is given 100 Newton, work is given 300 joules. So they are asking distance. As you know, what is the formula? Work is equal to force into distance. So we'll calculate what is S, because they have given F is given. Okay, F is given, W is given, but S is not given. So how will calculate that? Keep the S here, send F there. So if it is in multiplication, F will become in division. So S will become W by F. So put the value 300 by 100. The answer will come 3 meter. Now we will come to the second formula. Okay, first formula is this. For work we are having second formula also, that is work is equal to, just add cos theta here. Cos theta means it is a mathematical angle. Okay, when two lines are there, there is some angle between them. Okay, so type of the angles are there: sine theta, cos theta. If they have not come there, now they will come in 10th class also. Basically, what is cos theta? Cos theta is, just learn that first formula is only Fs, second formula is attach cos theta there. Cos theta means it is the angle between force and distance. Okay, now see how they can make the angle. So they are the condition of the formula. When you will apply, okay, they will ask, okay, write down the formula for work. So you will think, okay, what formula you have to write down. So you are having two conditions. If the condition will, they will ask, okay, they will not give any condition, write down force into distance. If they will ask, okay, angle they are giving, okay, 0 degree, 90 degree or 180 degree, you will write down this formula, attach cos theta there. If any doubt is there, you can ask me, you can send the audio. Okay, now see, now they will come the value of the work. Okay, three type of the values are there, means I have given you the formula, then they will give you the numerical. So what kind of the value you will get? What kind of the value? Here you will see the work value is positive, okay, 300 joule, but work can be negative also, it can be 0 also. So what are the condition? I have tried to explain that according to the example. Okay, now see, there are three possible values. Either it can be 0, positive, or negative. Okay, how it can be 0? See, there are two situations, because two formulas are there, no? So according to two formula, we are having two situations for all the three values. Okay, so first 0, there are two situations. Okay, first we are applying the force, but displacement is 0. How will you will say, okay, work is 0? Like I told you, no, if you are working on the computer, so the buttons are not moving from one place to another place, so then you will say that S is 0, displacement is 0. So if S is 0, then you will put the value here. If S is 0, so work force into 0, work will be 0. For the same thing is there, if you are pushing a wall, okay, you are doing the work, means you are not doing the work, sorry, you are applying the force. Suppose to 20 Newton force you are applying, but wall is not moving. Now wall is at same place, so the distance or displacement of the wall is 0. So apply that, write down the value, so it will be 0. So in any case, if the displacement is 0, work will be 0. In second situation or second formula, this was the first formula. Second formula, how the value can be 0? If the angle is 90 degree, then you can say the work done is 0. So you can see, if you are going to a train, a railway station, then you have seen what you have seen, that the coolie are carrying the weight, okay, on their head. So means they are pushing it. Okay, suppose this is the bag. Okay, this is the bag. So these are your hands. So you are like holding it, and you are like doing it, and you are walking. This is you are walking like this. You are walking like this. So means your force is upward, because you are holding it, okay, and you are walking in this direction. So force is upward, but your walking is this side. So it means F is in this direction, and displacement is this direction. Okay, so and S. What is angle there? 90 degree. See, you are holding it in this direction, in straight direction, but you are moving in this direction. So displacement is 0. We are talking about the box. Box is also moving with you now. You are taking the box. So that is it. So S is in this direction. You are moving in this direction. You are carrying the bag on this. So bag is also moving with you. So S is in direction. Force is in this direction. So the angle between this is 90 degree. So if 90 degree is there, you have to learn that 90 degree, here less than 90 degree, here greater than 90 degree. Only 3 situations are there for the angle. Either it can be 90, it can be less than 90, or greater than 90. Okay. So if equal to 90, it will be 0. If less than 90, it will be positive. Greater than 90, if it will be negative. Now I will tell you how to learn. If greater than 90, it will be negative. Now see here. Situation, there is a value. This was the situation number 1, means the 0. 0, how it can be 2, means 2 situations are there for 0. Either displacement will be 0 or the angle will be 90. Here also 2 situations. First one is both are in same direction. F and S are in same direction. You see here. What is the example? Like you are kicking a ball, or same like when you are like pushing a table. Okay, same this one. We will say this one now. This is what? This is the positive force. Because force is also in this direction, the table is also moving in this direction. F and S same direction, so it will be positive force. Normally in your life, what is the force? What is the work there? What kind of the work you are doing? If you are pushing a table, then it will be positive work. F is also same direction. You are kicking a ball. S is also in same direction. It is moving in same direction. Displacement is same direction. Situation number 2. If the angle is 90 degree less, okay, means less than 90 degree. The angles you know from the maths. No. Now see how. What is the example? If a child toy, this is the toy. See, some toys are there. No, the boy is moving in this direction. He is moving in this direction, but it is having a thread. Okay, so thread is there. So if it is like pushing like this, so he is applying the force like this. This is the application of the force in this direction, and this is the box. Okay, this is the box. For example, this is the thread, this is the thread, and this is the thread. No, this is the box. Okay, this is the box, this is the thread. So this is the box, this is the thread. So there the angle between them is what? It is less than 90 degree. It will be 90 degree if it is like this. This is the 90 degree. Okay, but it is not 90 degree. It is just tilted like this thread. So it will be less than 90 degree. So if the angle is less than 90 degree, it will be positive. Okay, so two situations are there for positive. Either both are in same direction or less than 90. Now when we will come to the next one, that is negative. In negative are also 2 situations. First one is F and S are opposite direction, or the angle is greater than 90, or you can say the angle is 180 degree. Okay, so you see how F and S is negative, means how the work is negative. Force, suppose this is the car and this is the road. Okay, this is the road. For example, the car is like sliding down. Okay, and the person is standing here. He tries to stop it. Okay, don't just fall on me, otherwise I will be crushed. Okay, so he is applying the force. Okay, don't just move it. So force, it is moving in this direction. So its displacement is this direction, and you are applying the force in this direction. So both are in opposite direction. In that case, the work is negative. Now, if angle is 180 degree, the same thing. Okay. See, if you are throwing a ball, you are holding a ball. So you will hold the ball and you will throw it upwards. So what will happen? If you will throw it upwards, then what will happen? It is moving in upward direction. So its displacement will be upward direction. But if you will ask about the earth, so if earth is there, so what will happen? Earth will pull it downwards, because you see acceleration due to gravity is it is a pull force. It will pull it downwards. So Fg is downwards, displacement is upward. So the angle between them is 180 degree, means it is greater than 90. So if you will make a list, so how you will make the list? You just see here, I will make the list. Okay, one small table. So that you just see here, what is a small table here? Situation number one, first situation is what? First situation is if displacement is 0. Okay, then work will be 0. Second situation is what? Second situation is if angle is 90 degree. Two situation, here also two situation. If direction is same, direction is same. And second situation is if angle is less than 90 degree. I will attach them if you need it. Okay, here if the direction is opposite, direction is opposite. Okay, you need not to study the book, but if you are like thinking about the book, then just go through. If any confusion there, you can ask me. Okay, so distance, if displacement is 0, then this is the 0, this is for 0, this is for positive work, 0 work, positive work, here negative work. You have to learn because they will give you the marks. Okay, now displacement is 0, angle is 90. Theta is a, like, it is a symbol for angle. You have to write on the symbol and the meaning of them. Okay, then if direction is same, which direction? Force and displacement's direction. Here also force and displacement direction. Okay, this angle is between force and displacement. So if direction is same and angle is less than 90, if direction is opposite, angle is equal to 180 degrees, then it will be negative work. So this one, this was the full work. Okay, so work here finishes, then we will start the energy. So what is in work? We'll do the revision. So symbol is what is the formula? Formula R2. Okay, then what is the SI unit? 2 SI units are there. What is the nature? Then when you will say the work done is there, how you can learn this? This question will not come. It is only to clarify your concept. What is the meaning of work done? Normally you will not say the work done. The work done is real life and physics. It is different. Okay, so you have to understand F and S should be there. So just fit F and S in your mind. Okay, then this is the like basic information about the work, and that it is what? It is the nature of, value of work. So 3 values, this you have to learn, and the work is finished. Okay, 3 values and three value, and for all the 3 values we are having two situation, then done. This can come, so you have to learn the examples. Any kind of the example you can learn, or you can search in the book or anywhere, wherever you are feeling comfortable with. Okay, then the second topic is energy. So what is energy? So energy is what? It is known as capacity to do the work. Now what happened? The work will convert into the energy. Basically work is what? Energy and work is same. Earlier it will be a work, and then it will change into the energy. Okay, so basically work, what is work, what is energy? Energy is equal to work. There is no formula. The formula is this one only. Okay, no particular formula is there. It will be change, but the basic formula of the energy is W is equal to E. It is energy. Energy is equal to work. I will explain this while we will do the next topic. So don't confuse it. Don't confuse about by this. So what is E? Now the next symbol is E, capital E. It is a symbol of energy. So now comes SI unit. So if the SI unit of work is joule, then SI unit of energy will be joule. So both are the same. Just the shape, like you can say the change. For example, you can say your book is same. Okay, but you have changed the cover. Earlier it was red color, now it is green color. Book, the inside the book pages will be same, content will be same, things will be same. You have to change, you have changed only the colored paper. Okay, earlier it was older, now it is new. That is the difference, otherwise no difference is there. Okay, so work and energy is same. It was earlier known as work, like one day before it was known as work, now it is known as energy, just like that you can say. Okay, now otherwise you can think about you are like in the 6th class, now you are in 7th class, you are the same person. No, just only the difference is what? Some energy is there inside your body now. Energy is increased, your height increased. This same thing is there, work and energy. Okay, work and energy is same thing. Now think, there are so many types of there. Okay, so many type of the energy is there, potential energy and energy, that you know. What is potential energy, what is current energy? You have to write down by yourself, because I have explained so many times. What is potential energy? It is the energy at the rest. Okay. What is kinetic energy? Kinetic energy in the motion. Now in physics, the thing is, the game is what? Game is about the formula and the symbol. Okay. So here the symbol is there. Potential PE. Kinetic KE. These are also the type of the energy: light, heat, sound, mechanical, electrical, solar. Okay. Mechanical energy. Now think about it. Earlier we know potential kinetic energy. In your chapter, in this class, only one energy is explained. These type of the energies are not explained. You will learn about this energy in next classes. In this class, only one energy is explained. That is, sorry, three energies are explained: mechanical, potential, kinetic. Basically these three are like, these two are under mechanical, so only one energy is explained: mechanical energy. What is this? It is a combination of potential and kinetic energy. It means what? When you are sitting, you are having potential energy. When you are moving, you will be having kinetic energy. So basically you are same. It is about your change in position. So when you are sitting, it is potential. When you are moving, it is kinetic. It is your body only. Okay. So this is known as mechanical energy. So it is, this formula will come. What is mechanical energy? Potential energy plus kinetic energy. Now come. Now this can come as it is, like the laws of motion was coming. You have to learn them as it is, what is given. So it's just like atom is indestructible now. You cannot make it, you cannot destroy it. Same way energy, you cannot create it, you cannot destroy it, you can only change its form. Okay, form means what? Type. You can change the type. One type will change into another type. For example, potential energy will convert into kinetic energy when you start moving, as I have given the example by you are moving. Okay, so you can see here, if you are having a cracker, you will burst it. So you will say, okay, light is coming, sound is coming. How it is coming? It is coming because chemical inside the cracker, it will have a chemical reaction and it will produce light and sound. You can see in 7th class, 8th class, 9th class, so many like formulas, so many reactions are there where one thing is producing another thing. Okay, now what is the conclusion of law of energy conservation? They will give you the question, what is law of conservation of energy? So you will give this one, this statement, this example, and what is the conclusion? So what is the conclusion? Total energy of universe is constant. Constant means it will be same. So some person is dying, another person will be taking birth, same way. In this also same. Okay, now what is the nature? Actually in this chapter, all the three terms, work, energy and power, all the three are the scalar quantity. They are not having any direction. They are only having the amount, okay, quantity. Now think about it. The other unit. Okay, this was one unit. What is the unit of energy? Joule. I told you work is what? Energy and work is the same. So SI unit of energy is joule. Now, another unit is there. So now we will think about the formula. Actually here we have to, in this energy, in topic energy, we are having two formulas. Okay, two more formula. One, the basic formula is work is equal to energy. Okay, so from this small formula we will make two formula. So first formula is for household energy. Household energy means when you are settling, so what kind of the energy is coming in your body, in your house. So that is for this also. Household energy we are having different formula. Mechanical energy we are having different formulas. Okay, so energy we are having many formula. Work and power we are having same formula. Now see, if energy is equal to work, energy is equal to work, I told you work and energy are same. Okay, so you are pushing something, you are doing the work on it. Okay, so that work will save as energy inside that. Means if one thing is there, suppose this, it is having a potential energy now. Okay, now potential energy is there. If I will do the work, it means it will come in the motion. So now what I am doing, I am like transferring my energy into this one. So now it's potential energy plus kinetic energy. What is going on here? Now its energy is increasing. Okay, its energy is increasing and it becomes kinetic energy. So my work, if I will do work on anybody, what will happen? I am transferring that work into that body, and that work now enter into that body and it will become the energy. So that's why potential energy plus energy, more energy will be added, it will become kinetic energy. So now see here. Hmm. Okay, that it is a formula of power that we have done there, but you just think about it. Power, okay, power is equal to work upon time, that you will learn in the next, but if we are applying it here, power is equal to work upon time, it is another formula. So what will happen if power is work upon time? So work is equal to energy. Actually we want to know the formula of household energy. So it is like, it is coming in power, we are saying the watt. So power, we will say now, okay, power is coming in our house, so we will use the power formula. Formula of power is W by T. So in place of W we can use E, because E is equal to W. So what will happen? P is equal to E by T. So if we want to find out the formula of household energy, so what is the formula of household energy? E is equal to P into T. So if you don't want to learn this one, so what you have to learn? You have to learn these two formulas. Energy is equal to work, and household energy, this is normal energy. Household energy is equal to power into time. Simple. So if you have power into time, so what will happen? The SI unit of household energy will be power. The unit of power is watt, and the unit of time is second or kilowatt hour. Watt seconds, CGS, it will be changed kilowatt and hour, kWh. The same I have said here. So energy supply in our house, it will be in kWh. It will be not in joule. You will not say, okay, 110 joule energy is coming. No, no, no. You will say that my household will be having 16 kilowatt hour. Means in 1 hour it will be consuming it 16 kilowatt of the power. So power and time you will use there. You will not use force and displacement. Okay, no, you will not use force and displacement. Now this also you have to learn. 1 kilowatt is equal to 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. Means in our houses the electricity is coming, the energy is coming as kWh, but normally the SI unit is joule. See there, SI unit is watts again. Here SI unit is joule also. Here the SI unit is joule, no. So you have to learn first unit of the energy is joule. Second unit of the energy is watt second. Third unit is kWh. Okay. Now relationship between kWh and joule is 3.6 into 10 to power 6. So kilowatt hour is bigger unit. Now the next one is, this was a formula for the household energy. Now the formula for mechanical energy. So mechanical energy, we are having two type of the energy, potential and kinetic. Okay, so potential energy means what? It is the energy at the rest. Okay, it should be at rest, so not in the motion. So what I will do, this object is at ground, so what I will do, I will hold it, and on the roof I have to keep it. So I will keep it on the roof. So here also it is at rest. Now here it is also at rest, but I have kept it here. So what will happen here? It is having the height now. What it has now, you see, when anything is in, like anything is kept somewhere, so what kind of the, it is not in like which kind of the force is applying there, because we have to find out the energy, no. So we should know what is the like force, which kind of the force is acting there. So the force will be acting, work is equal to energy. Okay, this you have to learn, that is the main formula, work is equal to energy. So we have to find out the formula. Okay, see there in this chapter, from this chapter you will learn about the formula derivation means what? How we can make the formula. One formula we can make. Now see, in this energy is having one formula, that is work is equal to energy, but other formula we are making. Now how we are making the formula? By just combining one formula with another formula. You know E is equal to W, but you know P is equal to W by T. So we will combine them and make the third formula. When we are making the formula from the already known formula. Suppose you know 4 formula, and I will say, okay, you just combine some, put the some value, okay, just shuffle the letter and make another formula. This phenomena or this thing, whatever you are doing, it is not formula derivation. Okay, I will repeat again. What is formula derivation? It is formation of the formula. You are making the formula. Okay, so I'm giving you two formula and I'm saying, okay, make the third formula. Then you will say, what are you are doing? I'm doing formula derivation. So you know already work is equal to energy. This is one formula. Okay, now you know work is equal to energy. I'm giving you this. Okay, if the question will come, what kind of the question will come? Okay, derive the formula for potential energy. So you will start from there. You have to learn this. Okay, but you will say one object kept on the ground will be like, it will be hold and kept on one height. You are keeping it on height. So object number 1, it is like taken, you hold it and you will keep it on the top of the roof. So initial position of the object is A, final position of the object is B. It has traveled a distance. Here displacement is travel, but displacement you will not use. Why? Because what kind of the force is acting here? The force is gravitational force. Here the force is gravitational force. Or just think about it. Just don't move the object. Don't move the object. If you're confused about, don't move the object. Just keep somewhere. Okay. Suppose the object is here. So it will be having some height. Okay. Suppose an object is here. Suppose it is on the earth. So from the center of the earth, it is having some height. That is the radius. Okay, otherwise don't think about it, just think about it. If you are okay, I will give you another better example. This is earth. Okay, suppose this is the table. Okay, and I am keeping one object here. Suppose one object is there. Okay, one ball is there. So from the center of the earth, what is the distance? Okay, you are not doing anything here. What will be the distance? It will be not the displacement, it will be height. We have done in the last also. Change as per the gravity. Okay, in gravitation chapter we have done, we have displaced, we have changed as with the h. Okay, as with h. So here displacement will be not there, it will be h only, because you are keeping it here, you are not moving it, you are finding the potential energy. So it will be h. So work is equal to energy. Now what is the formula? Work formula is F into S. So write on the same, F into S. We are not doing anything. We will just change the letters. Okay, so English letters we will change. F into S is equal to potential energy. Now work is energy, no? So energy can be any type of the energy. This is normal formula. So we are deriving for, we are making the formula for potential energy. So write here potential energy. So work is equal to potential energy. Now potential energy short form is PE, and work is force into displacement. Now what is force here? Force is mg. Mg means ma, but here as you are saying earth, so a is not a will be g here, because you are dealing with the earth. You are dealing with the potential energy. Potential energy means what? At the rest. So at the rest it is there. So it will be mg, not ma. H, mg into S is equal to potential energy, and S will be H, so it will be mgh. So the formula of potential energy will be, what will be the formula of potential energy? It will be mgh, where m is mass, g is gravitation, acceleration due to gravitation, h is height. Now you will tell me what is the value of g. Okay, now this is the potential energy formula derivation. Okay, you can tell me this one. Just you can make this diagram also, it's your wish. One earth, one table, on the top of the table this is the object, height will be h, and then just write down W is equal to E. W is equal to potential energy, write down the formula force into displacement, then formula force mg, and replace the S with then you will get potential energy unit is equal to mgh. Now we will come to the, this is potential energy is equal to mgh, mass, acceleration due to gravity, and height. Okay, now the next one will be the next. Okay, you have you have derived the formula of three formula you will derive here in the energy. Basically there will be the four formula. Okay, one is work is equal to energy, normal. Okay, W is equal to E, work is equal to energy. Then second one is energy is equal to work. Now energy is equal to P into T, and it's equal to P into T. We'll make the table here. If you are confused, we'll make the one table here. We will make the formula of energy. Okay, we will make the table here, formula of energy. Okay, so first formula is energy is equal to work, or you can say E is equal to W. Okay, so this is the first formula. Second formula is what? E is equal to P into T, power into time. Third formula is, it is potential energy formula, it is mgh. And then there will be coming fourth formula, that is kinetic energy is equal to half mv square. These are the formulae of energy. Okay, so four formulas are there. You will write down, don't worry. Okay, now kinetic energy, how will you derive it? Question will come, derive the formula for kinetic energy. Symbol of the kinetic energy is Ke. So kinetic energy means motion, so it has to start moving. So if it will start moving, you will just think about it, mass, it should have one mass. Okay, write down here mass. Just learn the image is very important here. Okay, but you will start from the same time, same thing, work is equal to energy. There also in potential energy derivation also you will start from work is energy, and kinetic energy also you will start with work is equal to energy. Here also you will start with work into is equal to energy. Everywhere all the three derivation you will start with the common formula. So one formula you will start and you will make another formula. Now it will start moving. Initial, if it is at rest, u is equal to 0. Now it is in motion, it is v is equal to, it is final velocity. Okay, so if work is equal to energy, what will happen here? Work is kinetic energy. There we have written work is equal to potential energy. Okay, here you will write down work is equal to kinetic energy. Now the same thing we will do F into S. Okay, but here F is equal to ma, it will be a only, because it is not G. Okay, it is, you are not keeping it anywhere, it is moving. So m is ma into S is equal to, now you cannot change S into H. Why you cannot change? Because it is not change. Now just see, if it is in motion, no, so apply any law of the motion and find out the value of S. ma is not having any value, a you cannot have any value, so S, find out the value of S. So we are having this one, this is the law of motion. The basic thing is you have to find out the value of S. So v square minus u square is equal to 2as. Find out the value of S, it is v square minus u square by 2a. So ma into value of the S is v square minus u square by 2a. Cut a and a, it will become m into v square minus u square by 2. Now as u is 0, initial velocity is 0. So if initial velocity is 0, this will be cut. You will not have this one. So what you will have? mv square by 2. And that is the formula of kinetic energy, half mv square. So you have to learn this formula. Kinetic energy is equal to half mv square. Now the last topic is work. Energy. Work we have finished. Now energy. Last is what? Work energy theorem. It is given in hidden form in your book, so I have taken that one. So work is equal to energy. It is what work energy theorem is saying, the same, the formula it is explaining. It is saying amount of energy transfer, whatever energy is there in the body, it is what? It is amount of work. How much work we have done. If I am moving this one, whatever the, like, okay, suppose it is rest, it is at rest, so it is having potential energy. Why it will start moving? Or when you are starting a car, why it start moving? Because you are working, no, you are like putting the gear, or like the engine is burning. So what will happen? Engine burning will add some energy. So if you will work something, no, some work, in normal life, if I am giving you some box, okay, put it on the cupboard, what will happen? You will take it and put it on the cupboard. So what is it going on here? You are doing some work, and by work you are working on the box, so your work will go inside that box and it will become the energy, and it will increase the energy. This is the work energy theorem. Means work done by a person will change into the energy and store into the object. This is the same thing. Nothing is there, the same thing is there. So you see the box, you are holding the box, you will put it on the shelf. So what will happen here? Your work will become the energy. See here, your work will become the potential energy here. Now when you will put it here, okay, it will become at rest, so it is potential energy. If it will fall down, again this energy will become kinetic energy. So basically your work is becoming potential energy. So one energy, work will become the energy, and first one type of the energy will become the another type of the energy. It means energy cannot be created, cannot be destroyed. It is a work, only the form is changed. It is not making the energy. Energy is work, and work is energy. This is done. Okay, so work will convert into the energy. This is the work energy theorem. Work energy theorem, it is like hyphen there. So work and energy are the same thing. This is the thing. So here it is, the formula I will give you. Okay, another one page I will add. Now the last topic is power. So what is the power here? Okay, so it is a relationship of work with time. We have already used the formula there. So definition is what? It is work done per unit time. Two definitions are there. Here I am introducing one new word, that is rate. What is the meaning of rate in physics? Rate means you will divide anything by time. It is known as a rate. So learn that word. What is the rate? Rate is what? Divide it any by time. I will give you anything. Okay, rate of doing force. So what you will do? F by t. Rate of doing acceleration. So what you will do? A by t. So by t means it will be rate. Okay, so one formula of one definition of power is work done per unit time and rate of doing the work. Here per means divide and unit means 1. Okay, and rate means by t. Okay, power symbol is P, capital P, not small. Think about a small p is what? Momentum. Okay, so think about small and capital. So make a table. Now the formula, power is equal to work done by time. So its formula is what? Capital P is equal to work done. The formula, like symbol of work done is capital W and time is capital T or small t. Here small t is used, so you can use capital T also. So conclusion is what? What is the conclusion here? If I will say, okay, roll number 1 and roll number 2, who is more powerful? So how you can say who is more powerful? Work by T. So if you will say P is directly proportional to W, but P is inversely proportional to T. See, directly proportional, inversely proportional. So what will happen? If work will increase, power will increase, because straight line. If opposite line, what will happen? T will, if T, how power can increase if time is less? It means what? If you will do more power, if you will do more work in less time, you will be known as powerful person. Okay, and if you will do less work in more time, then you will be less powerful. These two things will be there. If some work you are doing in less time, you are more powerful, more efficient. Okay, now its SI unit is what? Power is equal to work by time. No, so work is what? Joule. Time is what? Second. SI unit. So it will be joule by second or watt. Same way in work also. So it is Newton meter or joule. Same way, joule per second or watt. Joule per second, how we can write down? Second way is JS minus 1. Okay, now what is 1 watt? What? This can come in the question. Okay, one more question can come. What is 1 watt? 1 watt is when 1 joule of the work can be done in 1 second. It is watt. How you can define it? Just learn this one. Okay, the formula. Then joule by second. No, so if 1 joule in 1 second, it will be 1 watt. That is same. And the last topic, here it will come. Other unit of the watt is kilowatt. 1 kilowatt, kilo you know na 1000. So write down 1000, simple. And this one you have to learn. 1 horsepower. Horsepower, basic unit is watt. What is 1 horsepower? If 746 watt is here, it is 1 horsepower. Nature as a scalar. Another formula of power is what? It is power is equal to force into velocity. You have to learn this because formula can come on this. If you want to know how it is coming, W by T, force. What is the formula of work? Force into distance. Now displacement by time is velocity. So it will come like this. Okay, so all formula I will write on one paper and then I will attach that one. Okay, so if any doubt is there, your chapter is finished. This one, I will send you the exercise. Okay, so if any doubt is there in exercise, then you can ask me. Okay.